go. And got it. And there we go. Okay. Again, yeah, welcome back, everybody, from spring break. Yes, many people still on spring break, apparently. Your midterms, everything in the class at this point has been graded. So we'll start today going over just that sort of administrative stuff, what the midterm looked like, grades, answers, and then we'll get into this new topic today about transactions and locks. And again, big picture, sort of post-spring break, second half of the course here, we're switching gears to, instead of talking about how to make SQL queries correct or how to make your data analysis correct, thinking more about what's going on under the hood and how that's going to relate to making it fast. And that's what this transactions and locks will be our first step in doing that. And it looks like Firefox here has decided to freeze on me for some reason. Probably that's because of Zoom. That'll probably fix itself here in a second. But so yeah. Again, okay, we're not muted. We have video. Admit and share my screen again. Allow, and it still says that I am recording, so hopefully that is all good. Okay, back over here. So again, on GitHub in this topic 7 transactions folder, and at the start over here, going over the midterm. So the grades, distributions posted up here. Lots of 100%. That was the modal grade in the class of 100%. Then sort of falling off from there. We'll go over the answer key here in a second. It's posted right here if you want to get started taking a look at that. I've also, in Sakai, I put some small amount of notes about certainly any time you missed points. There's probably like a 1-sentence note about why you missed points. But then the key over here goes into details and common mistakes. So we'll go over that here in a second. The grades overall in the class, still looking pretty good. But again, I want to, one last sort of thing here to highlight that if for whatever reason you're not satisfied with your grade on the midterm or in the class overall, I've just posted this SQL extra credit GitHub issue that you can take a look at. And the idea of this extra credit is that you can complete LeetCode SQL hard problems in order to get extra credit. The exchange rate is 4 LeetCode hard problems for 1 point of extra credit. You can find a list of the problems over here. And it turns out there are only 9 total problems. So because of that, you can get at most 2 extra credit points this way. And collaboration rule, you can't work with other students. It turns out there are not really a whole lot of problem resources for SQL Online that are reasonably advanced. And so I am open to having other extra credits opportunities related to SQL, but they're a little bit harder to find. So if students are completing these, getting these 2 extra credit points and want more related to SQL, I'll find something else. But I won't do that until people have gotten these 2 extra credit points. Okay. There is no handouts today. We will be going over 2 PDF files here in the repository later, but the printer was not working, so there's no actual handout today. Okay, so following this link right here, we'll go take a look at the midterm answer key for a little bit. And I just put the answers here into a file in the midterm repository called midtermkey.sql. After each of the prompts, I have my sort of solution right here, and then below the solution, some grading notes about that particular problem. So this first problem here is definitely the easiest of the 4 problems. Most people did fairly well on this problem. There were no sort of common mistakes that for people who did miss points. So I don't have a detailed grading note down here, but if you do have questions about anything about your grade for whatever reason, happy to go over those with you during office hours or after class or any other time. The main thing here on this first problem is just getting your joins all correct, connecting the customer down to the payment out to the country tables. Problem number 2 is one where a lot of people missed a lot of points on. Again, in problem 2, we have this, we're hiring a family-friendly actor to do a commercial. So this part was the same as a homework problem where you wanted actors in the family category, but not in the horror category. But then the thing that was different is that for each of those actors, you have to the total amount that customers have paid for that actor's films. And this total amount that people have paid for films was also a different homework problem. So this is somehow combining 2 of those different homework problems together. Most people did this first part correctly, but then there were a lot of problems on the second part of calculating the amount of money that people paid. My solution is fairly long, so multiple pages worth right here. The key thing is that at the top up here, I have a bunch of joins going on, and then a where clause down here filtering out the joins up here. What they're doing is they're getting the total amount that is being paid for each actor, and then filtering out the actors down here below. In order to compare, so I have some example solutions over here that are not correct. In order to compare those, I'm going to do a side-by-side thing here in a bit. Duplicate these tabs, move it side by side in Firefox here, and scroll down. So on the left-hand side, this is my solution on the left-hand side, and on the right-hand side, we're going to compare this to some student solutions that turned out to be incorrect. Maybe just quickly before doing that, grading notes. So it was, again, the problem divided up into these 2 parts here, getting the actors and the revenue. 4 points for the actors, 4 points for the revenue. Most people did well on that first part, less well on that second part. Let's see, saw somebody needed to be let in the room here, but I no longer see a button to allow them into the room. They're not in the waiting room. Okay, back to the midterm. Okay, this first common problem was that people were not getting enough money somehow in the amount that they were saying that each actor was sort of earning or coming in revenue. And this is a student submission over here on the right-hand side, sort of very common pattern that maybe 10 or so students had. And what's going on here, what's different from this solution on the right and my solution on the left, is that you can notice there's a lot more tables being joined over here on the right-hand side, a lot more tables being joined than in my solution. And in particular, those extra tables are these the category table over here in film categories. So this whole joining is actually including the category over here. And so when you do this category.name like this, oh dear, what did I click on? This one line category.name in family check, this is going to filter out a lot of movies, and that's going to affect your sum up here. But because the problem was saying that it wanted the revenue from all movies rented, this is going to filter out some of the movies that will not be included in the revenue. And so the correct solution was to not include the film category and category up here, but to instead have that in however you were doing the filtering. So in my case, in these subqueries over here, but there are other ways to do that besides subqueries. Another sort of opposite problem that many people had is that getting the revenue being too high for various reasons. Less common problem here. But this student submission here was a typical example of how that happened. And here this submission is actually very, very similar to mine over here. There's just a typo in, or not a typo, a mistake in how the joining was happening, that the customer ID is not a correct column over here to be joining the rental and payment tables together. Doesn't make sense to join those on the customer ID. And so that's doing something very weird, very unintuitive. And this was getting you numbers that were orders of magnitude higher than the real numbers. Let's go on to problem number 3 next. So this was, again, it's sort of 2 homework problems combined together. And my solution to this literally just combines them together with the except clause, that both of these 2 lines right here are copied and pasted from my solutions to the homework, accept those together, and then have one more join at the end to get the first and last names of those actors. But the real meat of the solution's in this subquery down here. A lot of students, I actually don't think anybody had this same sort of pattern that I had, so a lot of students did something different. There were a lot of ways to solve this problem correctly, but some common mistakes. The first common mistake is that people were hard coding instead of actually having the name Russell Bacall. Why is that doing that? Instead of actually putting the name Russell Bacall in your SQL query, you for some reason hard-coded the fact that he has actor ID 112, and that happens to be true for the database as it is right now, but it's not true in general. This should have the correct way to do this is to not hard-code these values, because there's nothing like intrinsic about Russell Bacall that is the number 112. You should actually be looking that up from his name. I was, I think, very generous, only awarding or only penalizing 2 points here, but I think that's a fairly ugly, gross mistake. You should always be actually using the information provided in the problem so that it always works in any situation. GitHub. Another common mistake here, if you're getting too many rows in your output for some reason, then that was probably because of not having filtering happening correctly. This example here is a very unfortunate example of a mistake on just a typo here on the name Russell, having a single L instead of 2 L's. So this entire select clause right here matches nothing. So this entire filter right here does absolutely nothing. And it would have been very easy to double check that this was actually correct by taking this subquery and running it, doing some sanity checks. But a lot of the, I think, mistakes that I saw students making somehow based or caused or could have been fixed by doing sanity checks, just making sure that subqueries were actually doing the things that you thought that they were doing. Last problem, problem number 4. There were a handful, I don't know, a little over half the class got this right. Handful of mistakes though. My solution here, I just have a select title from film, and then in the where clause, each one of these parts adding one sort of condition about the first one finding films that don't have the F in their title, the second one finding films that don't have the F in the actors, and the third part don't have F in their customers somehow. Most students who missed points here were getting too many rows for some reason, And the reason you were getting too many rows was almost always because you were having many things joined together up here at the top. And then when you do have many things joined together up here, your filtering down here is going to happen only one row at a time. And but if there are multiple customers who have rented a movie, just filtering out one of those customers is not enough because some other customer will have rented that movie, and so the movie will still be in this list up here. So the most common way of getting too many rows is part 3 was not working, that you were not successfully filtering off of the number of customers. Last notes on grading. I tried not to take off 8 points, the full amount of points on as many problems as I could, but if I had to do that in a couple cases, usually because there was a syntax error in your SQL that you submitted and I couldn't figure out at all what you were trying to do. Then a couple of mistakes not listed up above, a couple of -2s happened because of very small mistakes that people made. And so I guess if you got a -2 on something, you should feel fortunate that it wasn't one of the bigger penalties. If you have specific questions about grading, happy to talk to you one-on-one about those things. But any general big picture questions at this point on the midterm?
This is about the LEAP code.
Sure. Yep.
The problems require.
That's a good question. So for the LEAP code problems for SQL, I think all of their hard problems require that you subscribe. And so there is unfortunately no way to get around that. If you want that extra credit, then you have to pay for LEAP code for a month or whatever their shortest term is. Yeah. So unfortunate, but again, there's just really not very many example sort of problems related to SQL out there that are of a sufficiently difficult quality to qualify for extra credit. Good question. Any other questions? Okay. Let's shift gears then, and we will start talking about our new technical material. Hooray! For our this week and going on for the rest of the semester. Again, we are switching gears now. We're no longer, like I guess at this point, we're assuming that you all are able to write correct SQL queries. We're not going to be looking at SQL queries that are nearly as complicated as any of the SQL queries that you had to do for your midterm. So there's not going to be, at this point, any of these like multiple page-long SQL queries that you'll have to think about. There'll be maybe like, I don't know, 5, maybe 10 lines tops. But we're going to be focusing on, instead of correctness, speed, and all the issues that go around with speed. And the first major topic that we have to consider for doing this is this idea of concurrency. And concurrency, what it is it's when multiple programs are going to be using the database at the same time. And it turns out that if you're reading data, this is going to be trivial. And I have trivial here in square quotes because this is like the mathematician's version of trivial, which means that it's effectively impossible for an ordinary person. But a mathematician, something is trivial if it only takes you a month to solve it. And so reading data is trivial in that sense. We're going to be focusing, though, on writing data. And this is hard. And I mean, like, legitimately hard. It's widely considered to be the hardest problem in all of computer science, dealing with concurrency and writing data. And 2 high-level ideas about why that's the case. The first is that it's a major source of non-determinism in our programs. So we've talked a little bit about non-determinism. It's only come up so far in the sense of when you upload your programs from the Lambda server to GitHub, you might get different results if you didn't have the order by clause. But we're going to start seeing now a lot of more cases of non-determinism and how that can happen. And this makes reproducing bugs very difficult, so it makes fixing those bugs very difficult. Another difficulty is that we're going to see there are some impossibility theorems that actually prove that there are certain things that you really want to do, but you cannot do when you're writing data concurrently. There turns out there's lots of ongoing research on this topic, and there are very few best practices of things to follow. And so in this course, we're only going to scratch the surface of this topic. Not really, we won't be able to get into the really hard parts about this. There are many tools for managing concurrency. Most of these tools are introduced in an operating systems course in a CS program. So just some keywords that you should have at least heard once: semaphores, barriers, spin locks, mutexes. These are things that operating systems do to manage concurrency. They're, again, super complex to use in practice, and because of that, because they're so hard to work with, modern programming languages have introduced many language-specific concurrency primitives. Some common techniques are callbacks, the async await pattern, or coroutines. In Python, all three of these techniques are implemented in this async IO module. If you took CS46 with me, we briefly spent 1 week on dealing with async IO in this war dialing homework assignment. But real quick overview is that Python started doing this in 2015 with Python 3.5, and every new version of Python since then has been backwards incompatible with their previous versions, because every time they've decided that what they've done has been totally wrong and they need to start over from scratch. So that gives you a sense about like how difficult this is as a problem, and that people still don't really understand the best way to actually to solve this problem. For our class, we're not going to be talking about any of those techniques that I just mentioned. Instead, we're going to be talking about techniques called transactions and locks, which are the tools used by databases. Okay, today in class, our actual technical details, or our technical things we'll be going over preparing you for the quiz for next week. There are 2 files that you'll need that we'll be going over today, this quiz notes.pdf and this quiz example.pdf, both contained in the GitHub repo here, the topic 7. What they look like is this. They have a short set of instructions up at the top. And then a bunch of these sort of boxes with a bunch of SQL commands inside of them. So we'll be going over those here in maybe 5 minutes or so, but get those pulled up so that you are prepared to go over it when we do go over it. Also, there's no handout version of this. The printer wasn't working this morning, so I apologize. There's no physical copy of these files. But if you would like to take notes directly electronically in these files, for these quizzes, you will be allowed to use your computer again to access notes. And so if you take notes directly in the PDF file, then you'll be set for the quiz. You'll be able to use those notes in the quiz. Okay, again, back over high-level overview details. Because this topic is so hard and important, again, widely considered the hardest topic in computer science, you're not going to have homework this week. Your only responsibility this week for this class is preparing for the quiz next week, which will be worth 16 points instead of 8 points. Again, quiz next week, Thursday, not next class period, but a week from next class period. And these are the 2 files that we'll be going over. We're going to start with this file right here, this quiz practice problems. Maybe a high-level overview, this example. This is the actual quiz from last year's version of this course. So you can see the sort of level of difficulty of the problems here. Take a look at that. In class today, though, we'll be going over this quiz notes.pdf file, and this will take us definitely won't finish it all today, probably not all on Thursday either, and go into next week a little bit. But we're going to start with this today. Any questions about, like, just administratively where we're at before we start into this this file here? Okay. I'm going to readjust my screen here so that we have some terminal windows that we're able to see at the same time as these practice problems right here. And so on the right-hand side over here, I have two terminal windows open, both connected to the Lambda server. So maybe make these a little bit bigger here for a second. And on the left-hand side, let's zoom out just a little bit so that, let's try changing this to 90%. There we go. So we can see a full problem filling up the window at once. And on both of these terminal screens over here, it's going to be important that we have two terminals open at once and that you're able to see them both at the same time. On both of these two terminals, I'm going to connect to a running Postgres instance. And for this, for these quizzes, it doesn't matter where you get these Postgres instances from. We're not going to be using any existing data. We're just going to be running these commands in these sessions here, which will take our, which will use tables that are created actually in the problems themselves. So for here, I'm going to go into my SQL quiz folder, and we'll use the docker compose up-d, make sure Docker's running, run our psql command to connect, and same down here, cd prod sas SQL quiz, and connect with psql. And it's important that both of these two psql instances are connected to the same Postgres database that I ran the Docker Compose stuff in the same folder. But again, it doesn't matter which database you're inside of because we're not going to be using any data from any database. And then on each of these problems over here on the left-hand side, inside of each one of these boxes, you can see that these commands are divided up into two columns, a session 1 column and a session 2 column. And in each one of these, or session 1 here corresponds to one of these terminal windows, and session 2 corresponds to the other one of these terminal windows. The line numbers here, in this case going from 1 to 6 on the left-hand side, 1 to 7 on the right-hand side, these line numbers, you should think of them as like time, that you start running these commands from the top to bottom, and on each number there's going to be a command in exactly one of these sessions. So at the very beginning here, this problem 1, I have a command on line 1 right here that's in session 1. I'll make this top right terminal my session 1, and so I'll type in create table T, create table T, a int like this. Again, it's case insensitive, white space insensitive, so it doesn't matter exactly how you type it in. I just have to create this table named T with a column A right here and hit enter. And we do that. And then on session 2 over here, we can see there was no command at timestamp 1, but there is a command at timestamp 2 on line 2 right here, the select count star from T. And so down here I can do select count star from T. And we'll see that this table T does in fact exist now in the second session down here in the bottom right, that I can connect to it, and we're not getting an error because this table T was created here in the top right. So it doesn't matter which session these tables were created in, we'll have access to them from both locations. Let's go ahead and add them. And then we'll go sort of line by line, running these commands and seeing how commands in one session affect commands in another session. So at this point, we've done lines 1 and 2, and now we're on line 3, time 3. And in this case, this command here, insert into T values 5, this is happening in the session 1, the top right terminal window over here. And so I can run insert into T values 5 like this, that runs that command. I can also, so timestamp 4 is the same, insert into T, I'll press the up arrow, add a 6 right here, 5 and 6, run both of those. Now timestamp 5 is a select count star from T inside session 2 over here, so I'll press the up arrow to rerun that same command, a select count star from T, hit enter, and we can see that those two rows have actually been added now to this table T, and we can we successfully see them here. Once again, insert into T over here. Now the value is 2. Hit enter. Down here on the right-hand side, select count star from T, and we get the value 3 being printed out down here. So this first problem is illustrating us, or what we've just walked through is how to understand this problem here, how to understand that these two sessions, these two columns correspond to two different P-SQL instances that are being connected to the same database. And we've seen that if we're creating tables or inserting things in one session, we can have access to that information in the other session on that we're connected to at the same time. Pause at this point. Are there any questions about the mechanics of what's going on or anything so far? Everyone's on board about what's going on? Makes sense? Everyone's still on spring break? Question, yes. Question, why does it say insert 0, 1? Oh, okay, so over here, the question is insert 0, 1, what exactly is the meaning of this output down here? The insert is the command that just got run. Basically, every time that you run a command in Postgres, in P-SQL in particular, it's going to have some sort of output that tells you what happened with that command. So we can see create table, outputs create table. That just sort of lets you know that this command was created. When you're running interactively from Postgres, from P-SQL, that's maybe less important. But when you're running from a script, it's useful to have this sort of record that at this point the create table command was run. But the actual question here was what are these lines actually meaning? And so the insert here corresponds to, it was an insert command. The 1 over here is the number of rows that was inserted. In this case, it's just one row that we're inserting. And the 0, I forget exactly, but I think it's the number of rows that were not inserted for some particular reason. So it's just sort of like a summary of what this command up here did. Yep. Okay. So at this point, for problem 1, we've walked through the mechanics of what this problem is meaning, how to understand and interpret this problem. But we haven't actually talked about what you're responsible for the quiz. Up here in this instruction section, there's 4 things that you will be responsible for the quiz. Listed out here, 1, 2, 3, 4, the annotations that you'll have to make on each of these different problems down here. Parts 1 through 3 are things that we will cover here in a little bit. They're moderately complicated. Part 4, though, is relatively simple. Write the output of each select statement. So on the left-hand side over here in session 1, there are no select statements, and so there is nothing that we have to annotate over here. In session 2, there are 3 select statements, and for the quiz, you will have to write out the output of each of those select statements. So we saw that the very first time, this select statement right here, nothing had been inserted yet, so we got a 0, so we should write a 0 right there. This second select count star from T, there were 2 commands over here, this inserts, 2 inserts, and so we will now have 2 things that have been inserted. And then the last select statement over here, we're inserting, and then select count star from T. So 1 more thing has been inserted, and so we should get a 3 down here. 0, 2, and 3. I think probably relatively intuitive at this point once you understand just what the meaning of the format of the problem is. Any questions about what to annotate for the quiz? Okay, then let's go on to the problem 2 down here. The difference between problem 1 and problem 2 is that in problem 2, you can see there is this new keyword here on line 3 and 8, the begin and the commit keywords. Begin and commit do what's called creating a transaction. And so I'm going to do some annotations right here. You're not required to do these annotations for the quiz, but this is just like notes to be helpful right now. And everything that is contained within a begin to a commit clause, I call this entire thing a block or a clause, is a transaction. Transaction, and I ran out of space. Transaction is obviously often abbreviated as X, an X for the transaction. Let's walk through now exactly what's going to happen in both of these problems. The first thing, though, that's going to happen when I start problem 2 is that I run line 1 here, again in session 1. And so create table T, a int like this. But I already have a table T created from problem 1. If I run this and hit enter, we'll see that we get this relation T already exists. And so the way to think about each of these problems is that they're being run totally independently from each other and in their own totally fresh database instance. So the most correct way to get a fresh database instance would be to leave Postgres, run the docker compose down, like this. That'll disconnect. You notice that in the bottom right-hand corner, I was still connected to pSQL. It's disconnected me from pSQL, though, because I have disconnected from the database. The database no longer exists, and so nobody can be connected to it. And then rerun my docker compose up. When I do this, because the database is, in this case, not stored in a volume, it is not going to remember that there was this create table T command. And so now when I run a new create table T a int like this, there's not going to be any conflict about this table being already created. So this is the most correct way to start a new problem, is to bring the database down and bring it back up. Down here, I will also have to reconnect to pSQL into this second instance down here. I say this is the most correct way to do it because this will always work. It's also, though, a little bit cumbersome having to do all of these different commands, leaving Postgres, bringing the database down, bringing it back up. It's a lot of commands to run between each problem. There's something like 50 problems in this set of notes, and so you don't want to maybe have to do that every time. Another thing that you can do is just manually drop the table from the database. In SQL, in order to delete a table, the command is drop, and then table, then the name of the table, drop table T like this. That deletes the table from the database, allowing you to rerun the create table command without any conflict. So when you go from one problem to the next, you're welcome to either run a drop command to bring your database back to like a fresh state, or you can, if you want to be totally safe that you didn't forget anything, bring the database down and bring it back up. Any questions about that? How to go from one problem to the next problem? Okay, so problem 2, again, starting off, line 1, create table T a int. We did that in, it's right here in the session 1 in the top right corner of my screen. Line 2, timestamp 2. What's happening is I'm running select count star from T. So down over here, select, maybe first I'll try using the up arrow. Notice that I can't use the up arrow. I'm pressing the up arrow right now, even though you all can't see it. But nothing is happening because the history of my pSQL session is stored inside of the Postgres service, inside of the Docker container. And when I brought the Docker container down, it deleted that history. So I actually have to actually type this out, select count star from T like this, and hit enter. And we get a 0 here as the results because we haven't inserted anything. And so I'll add a 0 right there. Now line 3, this is the only difference between problem 2 and problem 1 is that in problem 2 on line 3, we have this begin keyword right here. Again, the begin keyword, begin like this, begin semicolon, this starts a transaction. And the output of begin is always just going to be begin like this. I will now type my insert commands, insert into T values 5 like this, hit enter. I'll do the up arrow now to insert the 6. So I just ran lines 3, 4, and 5 right here inside of session 1. And now in session 2 over here, let's run this select count star from T and see what happens. select count star from T, I press the up arrow to get back to that, and I hit enter. And you can see now that the answer over here is going to be 0 instead of 2. So the answer over here is 0 instead of 2. On problem 1, when there was no transaction, the results of the computation, the results of the commands that I was running happen instantaneously, and they're immediately visible to all other sessions that are concurrently connected. So these are, again, 2 different sessions that I have open over here, 2 different pSQL windows, 2 different terminals, 2 different sessions connected to Postgres. And because there is no transaction in problem 1, because there is no begin statement and commit statement, the results of the inserts are available immediately. So this has a 2 over here. But in problem 2, there is a begin and a commit keyword. So there is a transaction going on. And so the results of this computation, the results of these insert commands are not available immediately to the other sessions. And so when I run a select count star from T right here, I get a 0 instead of a 2. Going on from line 6 to line 7, insert T into values 2. I'll press up arrow, change this 6 to a 2, hit enter. And then up here, so that was line 7 that I just ran. I'll now run line 8, this commit line. And commit, what it means is that whatever computations you were doing, whatever modifications you were doing to the database, they are now available to everybody else, all the other sessions that are connected. So on line 8, I do commit right here, and that makes all 3 of these inserts now available to other sessions. In this second session right here, the bottom right corner, I'll press the up arrow, get my select count star from T, command back, hit enter, and now you can see that there is a 3 available right here. Or a 3 is the result because all 3 of those inserts have been fully registered with the database. They are fully available for other sessions to see. So again, summary between problem 1 and problem 2, the only difference syntactically, mechanically, is that there's this begin and commit keyword. This creates a transaction that all 3 of these insert commands happen inside of this transaction. And the contents of the transaction are only visible to other sessions after it has been committed. So here, line 6 is different between problem 1 and problem 2. In problem 1, no transaction, so the insert's immediately available. Problem 2, yes transaction, so those inserts are not immediately available. Super important concept to make sure that you have 100% down in your head, because we're going to start seeing some very complicated versions of that here in a second. So questions? Yes, Oliver.
The X that you have to the right of line 7, is that indicating that area, or is that indicating?
Sorry, everything that I wrote over here on the left-hand side, these was just intended to be notes, and that the X here is shorthand for transaction. So for the purposes of the quiz, all of this stuff right here, you wouldn't want to have it. Just me trying to say that this stuff right here is a transaction, and the X is common shorthand for the word transaction because transaction's awkward. It's just a long word to write. Sometimes you'll also see, instead of just X, you'll see X act, maybe. But that, so X act equals X equals transaction. Good question. Any other questions about problem 2? Hopefully mostly intuitive so far. Okay, problem 3 and problem 4, following the same patterns as problem 1 and 2, the same set of create table, select, and insert commands. The difference between problem 3, 4, and the previous ones is only on the last line over here. Here it says rollback, here it says abort instead of committing. So here, these are again happening inside of transactions, but in problem 3 and 4, the way we are ending the transaction is different than we did in problem 2. So in order to start problem 3, to walk through what exactly is going to happen with this rollback command, I have to reset my database somehow. In this case, I'm not going to bring everything down and back up, again, because that's just a little bit awkward, a lot of steps to do. And instead, I'll do my drop table command. I'll do Control-R here in this top right terminal, look for the word drop. There we go, I found it, hit enter, drop table T. And now I'm still at a fresh state. There are no tables that have been created. And so I can do a create table T, a int again, no error message there. Session 2, run the select command down here, has a 0. Up here again, begin, insert into T, values 5, up arrow, change that 5 to a 6. Down here on the bottom right-hand side, line 6, press the up arrow, run this select. We see that we're still inside of a transaction, so we have a 0. I guess I should be annotating my selects up here, still 0, 0. Same from the previous problem because we're still inside of this transaction. We're on timestamp 7 right now, line 7. Press the up arrow. This is happening in session 1, the top right terminal. Press the up arrow, change that 6 to a 2 in order to get this command right here, hit enter. And now we're on line 8. Everything that we've done so far has been the same as the previous 2 problems. Again, the only difference between problem 3 and problem 2 is that line 8, instead of saying commit to end the transaction, has the word rollback. And if I type rollback now, rollback and hit enter, what rollback does is it says whatever changes that you were previously making to the database, let's just totally forget about those changes and not do them. So if I do rollback like this, and then a select star from count T on the right-hand side over here, up arrow, hit enter, select count star from T, we get a 0 as the result. A 0 as the result down here. So in this case, this is still transaction over here, lines 3 through 8, still inside of a transaction. But these transactions, in this case, was not committed. We rolled it back. And so these inserts never had any effect, and they're not visible to the end user in any way. And so we have zeros all the way down. The only difference between problem 3 and problem 4 is that instead of rollback, we have the word abort. And the word abort and rollback in Postgres are synonyms. So abort is equal to rollback. Absolutely no difference at all. So I won't run through problem 4 here, but it's going to behave exactly the same way as problem 3 because the word abort and rollback 100% identical inside of Postgres. Semantically, at a higher level, at a user level, abort should somehow signal like an error happened, and a rollback signal that like it was an intentional, we want to get rid of this data without any sort of error happening. Other databases will might behave slightly differently if you have rollback versus abort, but for Postgres, they are 100% identical, and in particular for the purposes of the quiz, 100% identical. Any questions about any of those first problems? Okay, one of the key words for databases, for these transactions that will be coming up a lot is the word atomic. And in Postgres, all transactions are atomic. And what atomic means is that either everything happens or nothing happens. Either everything happens or nothing happens. And so here we have these 3 inserts inside of this transaction. This is a relatively simple transaction with only 3 things going on, but the atomicity of Postgres guarantees that either all 3 of these things will be inserted or 0 things will be inserted. You can never have a situation in Postgres where, say, 5 and 6 are inserted, but 2 is not inserted. That's would be a very major bug inside of Postgres. And if you were to find a situation where that would occur, you would be a very famous person in the databases world. Postgres is thought to not have any atomicity bugs at this point. Other databases, RDBMSs, also guarantee atomicity. So SQLite 3 and MySQL also guarantee atomicity. SQLite has the reputation of being very good about correctness in this way, in the same way as Postgres. MySQL probably was still extremely correct in terms of atomicity, but I think, again, that sort of culture of performance first rather than correctness first means that if I had to guess about any three of these databases, which one was going to have a bug discovered tomorrow about atomicity, I would guess MySQL. Some NoSQL databases, so they're, again, the RDBMS, relational database management systems. This is an M right here. These all are guaranteeing atomicity. Atomicity. NoSQL databases. So MongoDB being the most popular example, they make no guarantee about atomicity. So one of the things that makes a relational database relational, that makes it qualify as having this RDBMS like keyword, is that it guarantees that transactions are atomic. Okay, on to isolation levels, more technical things for the quiz. I think the stuff above, I mean, it might be not necessarily obvious how you would design something at first, that you have this atomicity property with transactions. But once you see some examples, it's all relatively intuitive. Isolation levels are the first thing where in this large packet of notes where we start getting into very, very unintuitive things happening. And even if the stuff above seemed like 100% totally makes sense, I don't see how anybody could make a mistake with it. The stuff below down here, at this point in my life, having done databases for, I don't know, 15, 20 years, I regularly come into situations where I make mistakes related to isolation levels. So very important to pay particular attention here. Okay, problem 5. Let's go over problem 5. And I will press Control-R, drop the table again, so we're back to a clean state, and we'll run through this. Problem 5. First, at a high level, notice the difference between problem 5 and the previous ones is that we have our transaction here on the left-hand side inside of session 1, but we also now have a transaction in session 2 on the right-hand side. And we're going to see how these two transactions interact with each other in different ways, and in particular inside of different what are called isolation levels. So session 1 over here, we'll start with Control-R, create my table T, A, int. So we've done line 1 over here. Line 2 is our first difference, where on the bottom right-hand corner over here, I'm creating a new transaction, begin, hit enter. And now we'll do select count star from T like this and hit enter. And still we have 0 as the result. So up here, still 0 as the result right there from this problem. Line 4, creating our transaction in the top right terminal over here inside of session 1. I hit enter. And then line 5, I insert T again, Control-R, rerun my insert commands, insert T, values. First comes 5, hit enter, up arrow, then comes 6. I've now run all the lines, all the commands from 1 up to 6 down here. We're on line 7 now, so I'll press the up arrow to rerun this select count star from T. Before I hit enter, though, I should remind us that we are all computer scientists. And again, part of being a scientist means that you don't just blindly do things. You first make a hypothesis and test that hypothesis following the scientific method. And so we should all be in our head before running these commands, trying to predict what are some of the possible outcomes of this command here. And my prediction, based just on the things that we've seen so far, is that because we're inside of this transaction on the left-hand side, and we have this atomicity property that either everything is going to happen or nothing is going to happen, and we've not yet committed things, we are still going to have a 0 over here. And the fact that we're inside of a transaction on the right-hand side is not going to have any effect. And so my prediction is that we're going to have a 0 over here on the bottom right. And part of the scientific method, again, is not just creating a hypothesis, but it is also testing, evaluating our hypothesis. So now I hit enter to evaluate that hypothesis, and we get a 0 over here, which is what I predicted. So at this point, the fact that we are in a transaction over here on the right-hand side inside of session 2 is not having any effect on our session, on our results. Line 8 over here, press the up arrow, change that 6 to a 2, hit enter, and now in this case we are committing this transaction, so I'll run a commit right here and hit enter. And so we've run lines 8 and 9, we're now on line 10, this select count star from T. So this is the first thing that might be different between problem 5 and our previous problems. The first thing that might be different. And now we're inside of a transaction over here, and the question is, are we going to be able inside of this transaction to see the information that has been changed while we were inside of this transaction? And the answer is that yes, we will. By default, even though we're inside of this transaction, you see that we've run this same command 3 different times, but we get different results from those select count stars. Line 11 over here, we're ending this transaction on session 2. We have a begin and we have a commit down here on line 11. In this case, because there are no modification statements inside of this transaction, there is no inserting, there's no updating going on, only selecting going on. It doesn't matter how we end this transaction. A commit will be identical to an abort, will be identical to a rollback. In this case, I wrote the word commit over here, but it doesn't happen to matter. So I'll write commit right here, end that transaction, hit enter, and then line 12 down here, select count star from count T. Once again, up arrow, hit enter, and we have a 3 down here as our result here. So in this case, this first example over here, we have begin, commit, and all of our select statements were inside of a transaction, but nothing changed about the outputs that we were getting. Any questions so far? Okay. Problem 6, we'll start getting to see some new things. And so problem 6, I'll press Control R, drop my table, drop table T, create a new problem instance. We'll do create table T A int, Control R, create table T A int. That was line 1. And now line 2 and 3 are different. We have a begin command over here, but now we have this big, long, complicated statement of isolation level repeatable read. Recall that in SQL, commands are terminated by a semicolon and not by a new line. So lines 2 and 3 over here, this is all one command. 2 and 3 are one command because they're terminated by a semicolon again and not a new line. I just didn't have enough space to fit this all in a single line, so that's why it is on 2 lines like this. But this is all just one command right here like this. So over here, begin, isolation, level, repeatable, read, hit semicolon, and that is lines both 2 and 3 happening at the same time. Now down over here, I'll press up arrow, get my select count star from T and hit enter. Now we have a 0 down here as our result. In the top right corner, I'm currently on line 5 right now, timestamp 5. I'll type my begin, create my transaction, hit enter, insert into T, values 5, up arrow, insert into T, value 6. I've run line 6 and 7 right now. We're now on line 8 over here. I'll do a select count star from T, hit enter, still 0, what we would expect because of the transaction that's happening on the left-hand side. And because, again, we're inside of a transaction and we have not yet committed that transaction, there's no way that we could possibly see these inserts that have happened. So I'll update 0, 0 here again like before. And now on line 9, I will press the up arrow, change that 6 to a 2 to run line 9 right there, and let's commit that, commit those changes. And we're now on line 11. And now we have the select count star from T. Down here in the bottom right-hand corner, I'll press the up arrow, rerun this command. And notice that I get a 0 down here as the result of this command right now. There is a 0 right here instead of a 3. In the previous problem, I got a 3 on line 10, but now on problem 6, I'm getting a 0 from this select count star from T. The only difference, again, between problem 5 and problem 6 is that in problem 6, I have begin isolation level repeatable read. So this, these lines right here, this isolation level repeatable read is the only part that is different about problem 6 right here. And intuitively, what repeatable read means is that if you run the same select query multiple times, you're going to get the same answer, guaranteed multiple times. And so here, because previously I have run my select count star from t and I got a 0, in the future I also have to be able to get a 0 from that same command. If I run the same command multiple times, I have to get the same output. And so because all 3 of these here are still inside of this same transaction, and this transaction has this new isolation level of repeatable read, they're all going to guaranteed get the same results, all getting 0s. When I do commit down here, line 12 in the bottom right-hand corner, commit, I leave this transaction, no longer inside of the repeatable read transaction. And so on line 13, press up arrow, rerun that select count star from t. Notice that on the session 1, there have been no changes. Notice that nowhere have I added new information between running this select command right up here and this select command down right here in the bottom right-hand corner. Nonetheless, I get a different result down here. I get a 3 instead of a 0. I get a 3 right here because there are 3 things that have been committed, and they are now visible to me because I am outside of my transaction, which was an isolation level repeatable read transaction. Any questions so far? Justin?
So the isolation rate,
This is a great question. The question is, does this isolation level guarantee that you get the results from when the transaction started? And I want to see what problem. The answer is no, and we'll see that here in problem 7. That the isolation level repeatable read does not guarantee that you get the same results for your select queries as when you started this transaction. And so let's go ahead and do problem 7, and then I'll come back for questions so that you can see the answer to this question here.
I have a question.
Problem 7, the difference between problem 7 and problem 6 is that in problem 7, there is no first select query after this began isolation level. This problem 7 has 2 changes. This is read committed and repeatable read. Well, so what repeatable read guarantees is that once we run this, we're going to get the same results in the future. So I'm going to do problem 7 now with a repeatable read here instead of read committed. So this is like a problem 6.5. I don't actually have it written out here, but I'm going to do problem 7 over here with repeatable read here instead of read committed. So in order to do that, I will seem to not be connected to the Lambda server right now for some reason. It looks like my, so I just switched terminals over here to a different terminal. This is my connection to the VPN. The VPN disconnected for whatever reason, and so I will reconnect. I forget if I pointed this out before, but I store all of the commands that I have to do regularly inside of a shell program, inside of a shell file, inside of a scripts folder on my home computer right here. So connecting to the VPN is something that I have to do regularly. So rather than trying to remember an incantation or having like a Word document somewhere where I go look it up and copy and paste it, I just have a shell script that I run which connects me and type in my passwords. Now I'm connected again to the VPN. Over here, unfortunately, I will have to delete or disconnect these terminals. They're not going to automatically reconnect to the Lambda server here. And let's see. Let's reconnect. Sorry that this happened. And let's go into the SQL quiz, the project SQL quiz, and let's just to make sure that we're in a sane state, bring everything down and back up -D, make things big again, and Control R pSQL, be connected in pSQL in both places. And then again, what the question was about the details of this repeatable read isolation level, and I'm going to do a variant of problem 7, or alternatively, think about a variant of problem 6 where we don't have line 4 right here, and we'll see what happens. So we'll do problem 6 without line 4 right here, and we'll see what happens. I'll type my create table t a int command like this. In the top right corner, again, the session 1 is the top right corner. Line 2 over here, begin isolation level repeatable read, hit semicolon, hit enter. Line 4, select is the line, this is the line that I'm going to delete, not going to run. And so I'm not running this select count star down here in the bottom right hand corner. And instead of running line 4, I'm going to skip directly to line 5 and create my begin transaction up here. Insert into t values 5, up arrow, insert into t values 6. And now at this point down here, I will do a select count star from t, hit enter. I get a 0. I'll finish this problem out, insert into t values 2, hit enter, commit. Down here, I'm gonna still get this select count star from 0 because I have this repeatable read right here, and commit, do this, we get a 3. Sorry, I meant to, instead of just deleting line 4, I want to delete lines 4, 5, and 10 in order to do this. So I want to delete this select right here and delete the fact that all of this is happening in a transaction. So I'm going to redo this example, Control R. I can't Control R that, I have to drop table T with a D in front, drop table T. Now Control R, create table T. Control R down here, begin the isolation level repeatable read, skip line 4, skip line 5, do the insert up here, insert into t values 5, insert into t values 6. Now down here, when I do my select count star from t, even though I'm inside of this repeatable read isolation level, because I've not read from the table at all inside of this level, I do not get a 0 here, I get a 2. The repeatable read does not guarantee that your results are the exact same as when you started this isolation level. Instead, they guarantee that your results are going to be the exact same if you run the same command multiple times. So the very first time that I run this command, it's going to look at what is currently available inside the table at that moment. And so the first select count star, the first count star here has 2 rows available. Up here though, if I insert another row, add this 2 right here, and redo a select count star down here, I'm still stuck with that 2 because I'm still inside of this repeatable read isolation level. Repeatable read just means that if you read the same thing multiple times, you're going to get the same results every time. So select count star from t, I get the same results down here, 2 and 2, even though I've added new things up here and even though they are still visible up here. So there's no commit to do now because I'm not in a transaction. But if down here I commit and then rerun that select count star, now I have a 3 available. I see lots of hands up for questions. But again, real quick summary of what I just did is the original question was, what exactly is the guarantee that the isolation level repeatable read does? And in order to show an example, I have deleted lines 4, 5, and 10, ran all of those other commands. And so when I had this select statement right here, the very first time it saw these 2 rows as being available, but multiple select statements from this that are exactly the same are guaranteed to give me the same exact results. Henry.
If we have a command that's like when instead of people read, if we have a command that's equivalent but not like letter by letter the same, so if we were to say select count star from t when there were only 2 in there, then we were to say select count star from t where a in.
It's a fantastic question.
5, 6
So
would still, yeah.
I'm going to restop or restart a new problem here, drop the table and Control R, create table T, aint, recreate my repeatable read, begin isolation level repeatable read. So I've run lines 1, 2, and 3 at this point. I'm not going to run line 4, I'm not going to run line 5, but I am going to run lines 6 and 7 over here, inserting into the values 5 and 6. And now in order to trigger this repeatable read characteristic, I'm going to do select count star from T over here, hit enter. And on the left-hand side over here, I will now once again do my insert into T values 2 like this. And first verify that select count star from T is still going to give me the same exact results. The original question though was, so we've seen now that the same command is going to give you the same results. But what are the variants? Like how sensitive is that to the, how sensitive is that sameness? And later on in these notes, we'll talk in detail about the sensitivity of that sameness, but we'll just do some examples here right now. So the immediate question was, do things have to be exactly syntactically the same? And the first answer is no, that like syntactically things don't have to be exactly the same. It's not like an exact string match between commands, that if two commands are semantically equivalent, they're guaranteed to give the semantically same results. But so here from T, another semantically equivalent command in this case where let's see. I don't want to try that where clause at this point. Something that's semantically slightly different, though, here would be the count star from T. So again, the count star, this will actually list the rows instead of the count of the rows. And so this will list all of the rows that are currently available for this transaction to see at this table. And when I hit enter right here, you'll see that only rows 5 and 6 appear, and the row that has this 2 value does not appear. Why is that? Again, it's because of the repeatable read. This insert T values 2, this did not exist when we ran this first select count star from T. And one of the things that this select count star from T sort of depends on is that like it first runs this and then it counts the results. So internally we had to run this command in order to run this command. And so this command is also something that's guaranteed to give me the same results with this isolation level repeatable read. Technically, what isolation level repeatable read guarantees is that if a command touches a row in the table in any way, or touches what's called a page in the table in any way, that you're guaranteed to get that same row result back as you had before. So again, we'll talk about the details of that later on. It is extremely complicated, all the subtle like cases, but that at this point, for the purposes of the quiz, what you need to know is the basically just that it's a copy and paste command. For the quiz, it's always going to be something like count star, something that's easy to write the result over here with. This is also a good sort of segue into a, I'm just noticing the time right here, so I want to be respectful of time. We're going to stop here, and we will pick up here on Thursday in class, talking more about these edge cases and again, very complicated material coming up. It'll be definitely the hardest in this course and hardest in all of computer science. So we'll stop there for today. If anybody still has more questions about the material or the midterms or anything about the class, I'll stick around and get those answered.